have to intervene with one thing. So if I have x squared minus 4 greater than or equal to 0, and I make this terrible mistake, and then I make the terrible mistake of taking the square root from both sides, I will get this. So this is what this means. X greater than or equal to positive 2 and x greater than or equal to negative 2. Well, where actually the solution is negative infinity, negative 2, union 2 to infinity.
All right, I understand now.
Excellent. So after we completed that, we had to remove x equals negative 5. This is what I consider an elegant way of determining or studying the sign of a product or ratio. If I don't have a product of 2 or more factors or a ratio of 2 or more factors, I cannot use this procedure. We study the sign and then we determine the sign of the outcome. We stated the domain of a log function. This quantity has to be strictly greater than 0. Log cannot be applied to 0 or negative. Then we looked at piecewise defined functions, and we said every time we are asked to graph a function, we have to find its domain first. That is the absolute first step. After that, I prefer, but you can invent your own table. If you don't like this table, you can use your own, but you have to present a organized table, whatever, but an organized table. So here it shows that I see that there is a jump. There is a full point at 0, 1, but there is an open point at 0, negative 3. If both of them are full points, this is not a function by the vertical line test anymore. And then the range of the function from the lowest y value to the largest y value, where the function exists. And this function exists from negative infinity till 1. The average rate of change of a function between 2 points. We don't have to draw this line, but it's the same thing, and it's easier to remember that the way I determine the average rate of change of a function is the same as determining the slope of a line. Exactly the same procedure, exactly the same rule, and the same formula. Then we talked about the difference quotient. I don't know what they're doing outside. The difference quotient is exactly the average rate of change, but is the average rate of change of a function between 2 points that are very close to each other. This is a tiny value. So it means that A and B are very close to each other. And we determine the average rate of change, which moving forward is the difference quotient, and it has to be memorized. F of x plus h minus f of x over h. And this is the rate of change of the function f of x between a and b, and it's almost, not exactly, it's almost the instantaneous rate of change. And we picked a function, or we were given a function, and we determined the difference quotient. We put all the 3 pieces together, and then we evaluated and simplified the difference quotient. 2 things are mandatory to happen every time we determine the difference quotient. Mandatory. All terms without h found in the numerator, all terms from the numerator without h must cancel out. Then at the very end, I'm trying to keep my system going with the other 2 computers I have here. And h from the denominator must simplify, and you see it did. So all terms without h went away. All these terms that we crossed out went away because they don't have h and they have to go away. I cannot fabricate that process. If they don't go away, I have to go back to the drawing board. I know I have an error somewhere, but they do go away. And at the end, I factor out age and I simplify, and this is the final form. And you will see very soon what this represents. Furthermore, in addition to the difference quotient of a function, or the rate of change that it's between 2 points that are so close that it's almost the instantaneous rate of change at that one point. Okay, so this was what we covered last time, and now this can go to recycle. And I'm waiting for your questions before we start today's lesson. Anything you have in mind? Anyone? I think Gia was first, and I think who was next? Becky. Becky was second, and so on and so forth. So please ask. So for the skills assessment, it's due on Saturday. Please, if you need extra time, I'll extend it, but I would like to finish it up so we can start. So we did several problems from here. We did the piecewise defined function. Anything else you need? We need the we did the difference quotient. Oh, we did not do 13, and I want to do 13. The ratio. I'm sorry, rational equations, etc., etc. So what do we have first? What do you have for me?
Can we go over 6?
6. What does 6? What does 6 say? Where are you, 6? Graph the function e to x plus 2 minus 3. So it's a very good question. The exponential function and the log function moving forward. Please make sure you know the graphs by heart. So e to the x is an exponential function, and the graph is increasing on all its domain. This is e to the x. In general, it's a to the x when the base is greater than 1. And unfortunately, when they said about the coronavirus, they said to flatten the curve. We wanted to flatten the curve. We didn't want an exponential increase of people infected, but that's what happened. It was an exponential increase. We wanted to flatten the curve. So that's the exponential function with a base greater than 1. And I also want to remind you of the graph of the exponential function with a base less than 1. We would have definitely preferred this. This is still a to the x, but here a is between 0 and 1. We like that one for infections. We like that one for something else, but not infections. Okay, so now the natural log is the inverse function of e to the x. So this is the graph. They have to be symmetric with respect to y equals x. So here is the graph of natural log x. Of course, this is 1, 0, and of course, this is 0, 1. They are inverses of each other. So they are extremely important for many reasons, because we are going to get to limits, and this one, as x approaches negative infinity, the function approaches 0, and when x approaches infinity, the function approaches infinity. This one, when x approaches infinity, the function approaches infinity, but on the other side, in other words, when x approaches 0, the function approaches negative infinity. So very important graphs. Please remember them together. And if you want, I can put here y equals x, and I will copy e to the x so you can see they are symmetric with respect to. So natural log and e to the x are symmetric with respect to y equals x. Very important graph. When the base, of course, is less than 1 for the log function, where at the point where the function crosses y equals x, at that same point, its inverse must cross. So this is log base a of x with the same base between 0 and 1. As you notice, this is decreasing and so is this. This is increasing and so is this. So in order to graph e to the x plus 2 and minus 3, you graph using transformations. That's I recommend that's the best way. You graph e to the x first. What does the change of x plus 2 does to this graph? Anyone remembers what transformation this is?
Move it to the right, to the left.
To the left, yes, to the left. So
And
it
then
shifts.
move it down 3.
And then down 3. Excellent. Well done. So this will be e to x plus 2. But now I have to be extremely careful because something else needs to be graphed. This function, we'll talk about that sooner rather than later, has a horizontal asymptote. When I shift the green graph down 3, I first have to shift the original asymptote. That was at y equals 0 and now is at y equals negative 3. After that, I can shift the function. So this point, which is at negative 2, 1 is here, should have crossed at the same point. I have to shift this 3 units down, and then the graph. It does not touch the horizontal asymptote. So this is e to x plus 2 minus 3. All my skills assessment problems are in the previous videos from fall and spring of 2019. I highly recommend watch those videos just for a refresher, and the problems may be slightly different if students had other questions, so I think it's a very good idea. Good functions, please remember those. Okay, anything else for me?
Could you go back to that where you had the graph for 1 second?
Oh yes, of course. Is there anything else from the skills assessment other than problem 13 that I would like to show?
Yes, can we go over 8?
8. Where
Sorry,
are
I
you?
warned you.
Yeah, it's the same thing. We did this together. We did natural.
Okay.
We did. Yeah, we did the log. Log base 3 of x plus 4 is the same with natural log of x minus 3. Same
Okay.
idea. You have to state that x minus 3 has to be greater than 0, and then plot. Because it's the same thing with this. Is natural log x. And x minus 3 will shift the graph to the right 3, but you also have to shift the vertical asymptote 3 units to the right. It's the same graph, but shifted to the right 3. Is
Okay.
that good enough?
Yeah.
Let me know if it's not. So you have to shift the vertical asymptote at 3, and your graph will start at, you will cross the x-axis at 4. That's it. And you have to state the domain that x minus 3 is greater than 0. Anything else?
Let's see what's up. Can we look at 11 too?
11. Yes, this is a very important type of problem. Because remember, when we create the function composition, function composition is f comp g. I can also have g comp f or any other combination, but it doesn't matter. This means f of g of x. It means g is the inner function. You see it here, it's the inner. And it means that f is the outer. This is very important for the chain rule. So if I'm given f of x, which in my example is 1 over the absolute value of 2x minus 4, one function takes priority. Which function? So let's say you're asked to evaluate this function for x equals 3. Which portion of it will you evaluate first? Will you evaluate the absolute value? Will you evaluate the quotient? What will you evaluate first?
Would it be the absolute value?
I can't. I don't have the number inside. So what will be the inner function? And the outer? What will I have to evaluate first? Before I get to the absolute value, I have something else to evaluate, which is
2x minus 4?
absolutely. Now I got one. Where is my tiny eraser? I lost my tiny. Oh, here it is. Now I got a number here. What will I evaluate next?
2 times 3 minus 4?
Oh, I already did that. I have one number here. It's done. It's 15.
Okay.
What will I evaluate now?
1.
Over
15?
X.
the absolute value of 15. Very good.
Oh.
But in this case, it's x, of course. So now when I create f comma g, I guarantee you will get uppercase f of x. Because you will have to plug this function in here. And you get 1 over the absolute value of 2x minus 4. Is that okay? Any question? Say it again.
I said I get it.
Good. Other questions? Thank you. Anything else on this problem? Everyone?
It's me again. 14, and then I promise I'm done.
No, I have to show 13 first before we look at 14.
Oh, there we go.
So in 13, we have something like x minus 1 to the third times 6 times x plus 2 cubed minus 3, x minus 1 squared, x plus 2 to the fourth, everything over x minus 1 to the fourth. Let me give you a second to copy this.